In this video, we will solve multi-step equations with variables on both sides of the equal sign. The steps to solve equations with variables on both sides start with using the distributive property to get rid of any parentheses. If there aren't any parentheses, we can skip this step. Number 2, we're going to combine like terms separately on each side of the equal sign. Next, we'll choose which side you would like your variable to be on. It doesn't matter. The operations there just have to be undone to move to the opposite side. Number 4, solve using the rules for equations with variables on one side. And then after, check your work by using substitution. Remember, the goal is to isolate the variable to be able to know its value. So we have to get one variable equal to its value at the end. So let's start with the example 5y minus 8 equal to 3y plus 12. So we don't have any distribution, so we're going to skip that step. We don't have any like terms that we need to combine on each side of the equal sign, so we can skip that step. So next, what we need to do is decide which side of the equal sign we want our variable to be on. Let's go ahead and choose the left side for this example. So I'm going to split my paper down the middle, and I'm going to move the 3y over to this side. The way I do that is I have to cancel that out from the right-hand side. So how do I get rid of a positive 3y? Well, I have to subtract it from both sides. So subtracting 3y from this side, and that term goes away. But I have to do the same thing to the other side, and I'm left with 2y minus 8 equal to 12. Now we have the variable on one side of the equation. So now this looks a lot like our two-step problem or our variable on one side. So from here, I'm going to add 8, and I have 2y equal to 20, divide by 2, and our y is equal to 10. So to check our answer and check and make sure that this value is really the value of y, we're going to check by substitution. The value of 10, when we plug it in, should make the equation true. So 5 times 10 minus 8 equals 3 times 10 plus 12. And when we work out both sides of that equation, we end up with 42 equal to 42, which is a true statement. So therefore, our answer is correct. Y is equal to 10. All right, for these next examples, I want you to use the example I did and isolate the variable. And please check your work by substitution. Same with this example. Next, let's try one where we have to distribute. So here we notice the parentheses and we have to distribute the 3. We also notice we have a variable term on the other side of the equal sign. We're only distributing the 3, though, to the set of parentheses it's in front of. So I have to distribute the 3 to the 6 first and get 18p, and then I distribute to the negative 1 and get a negative 3. And I just bring down the rest of that equation. Now I have variables on both sides of the equation. I've simplified both sides, so now I need to move the variable term to one side. It doesn't matter which side of the equation you work with. So let's move the 11 over. So we have to cancel it out from the right-hand side by subtracting 11p, and we subtract 11p from the other side to end up with 7p minus 3 equals negative 45. Don't forget to bring down that sign in front of that 45. From here, we need to move the 3 over by adding it to both sides. Notice how we're undoing those operations. That leaves us with 7p equal to negative 42. Now I'm dividing by 7, so the value of p is negative 6. Now that we know p is negative 6, let's check our work and plug it back in to the value of p to see if we got our answer correct. So we're plugging the negative 6 wherever we see that variable. So 3 times 6p minus 1 equals 11p minus 45. So working the left-hand side, we get 3 times negative 37 equal to negative 66 minus 45. 3 times negative 37 is negative 111, and negative 66 minus 45 is also a negative 111. So checking this by substitution, we got our answer correct. These next two examples I want you to do, and I want you to check by substitution.